Calculus video 17, limits on piecewise defined functions. So we've seen piecewise defined functions in algebra. I have an example of one here. F of x is equal to negative 2/3 x plus 1 for x less than or equal to 3, and the square root of x plus 1 for x greater than 3. So let me draw the piecewise defined function, which splits 3, right? At 3 or less, we get this line, negative 2/3 x plus 1. But more than 3, to the right of 3, we have this square root function, square root of x plus 1. So for first the line, we have negative 2/3 x plus 1, so that's a slope down to right 3, starting with a y-intercept of 1, down to right 3, down to right 3. One of the, I think, the best ways to start this is to find out what the end point would be. So what happens at 3? If I were to plug 3 into the x value here, negative 2/3 times 3 plus 1, that's negative 2 plus 1 is negative 1. So at 3, I get the point 3, negative 1, 3, negative 1. And I have this slope, this line, which passes through the point 0, 1, and a slope of negative 2/3. Maybe not the best graph there, but something like that. Closed circle because of the or equal to sign in x less than or equal to 3. But it stops there because to the right of 3, we have the curve square root of x plus 1. Now that would be the square root function that's moved to the left by 1. So typically that graph would look, something kind of like that. But we don't get the entire graph. We only get that for this part 3, oops, not closed in circle. This part 3 open circle and to the right. Right? Open circle because it's x greater than 3, not greater than or equal to. So I need to erase the dots through here. What is that endpoint? And I didn't write it down here, but this endpoint was 3, negative 1. To find the endpoint over here, I will take the square root of 3 plus 1. That's the square root of 4. That's 2. That's the point 3, 2. And so we see this open circle occurs at 3, 2. And that is the graph of a piecewise defined function. Notice it is a function. It passes the vertical line test. If your piecewise defined functions overlap each other, like so, or you have something that does not pass the vertical line test, that's a problem. We don't want that. Let me just try this. No. Okay. Going back to our, let me erase this, it's kind of in my way. Going back to our original piecewise defined function, what I want is to take limits on the piecewise defined function. What is the limit as x approaches a particular value? In this case, we're probably going to look at what happens at 3 because that's when the curve splits. So for example, what is the limit of our function as x approaches 3 from the left? So as x approaches 3 from the left, here's 3. Approaching 3 from the left would be coming in this direction. And we see the y value is getting close to negative 1. So from the left, we see that the limit as x approaches 3 from the left is equal to negative 1. And that's it. What about the limit as x approaches 3 from the right, the plus sign there of our function? In that case, from the right, we're coming in on the function, on the curve, from the right-hand side, and we see that from the right, the limit of the function approaches a value of positive 2. And so this is equal to 2. How about the overall limit? The limit as x goes to 3 of the function, we see that at 3 there's the jump, right? The left-hand limit and the right-hand limit are not going to the same thing. Therefore, the overall limit does not exist. And that is because the left-hand limit does not equal the right-hand limit. Okay, a couple more. What about the limit as x goes to 8 of the function? Now the function didn't split at 8. 8 is somewhere over here. And at 8 being greater than 3, means we're going to use the green curve. At 8, we're looking at this point here. Right? What is the y value going to as x approaches 8, both from the right-hand side, left-hand side, and from the right-hand side. This is an overall limit as x goes to 8. We see it goes to some particular y value. Notice we're using the green curve here because, right, 8 is greater than 3. Therefore, we'll use the square root of x plus 1. And so we take, basically, the limit as x approaches 8 of just that portion of the function. Plugging in 8, that's the square root of 8 plus 1, that's the square root of 9, which is 3. Similarly, what is the limit as x approaches negative 3 of the function? So negative 3, right, is somewhere over here. That function will be up on the line, not the square root value. So we're going to use, since negative 3 is less than or equal to 3, we're going to use the line negative 2/3 x plus 1 to plug the negative 3 into. So the limit as x goes to negative 3 of the function is the same as the limit as x goes to negative 3. I apologize, I just realized that I wrote infinity up here. And that should have been an 8. There we go. The limit as x approaches negative 3 of negative 2/3 x plus 1. Plugging in the negative 3, that's negative 2/3 times negative 3 plus 1. That would be positive 2 plus 1, also 3. That's coincidental that both of those answers are 3. But you can kind of see, although not maybe the best drawing, that negative 3, 3 would be a nice point here, and 8, 3 would make sense for that as well. And that is limits on piecewise defined functions.